Hello everyone, welcome back to A4 Analysis. Today is the fifth episode of Study Statistics with me. In our fourth episode, we talked about different kinds of discrete distributions in a nutshell, and today we will be discussing about continuous distributions. Now, what is continuous distribution? Continuous distribution is same as discrete distribution. The only difference is this distribution is constructed from continuous random variable. Now the continuous random variables are those random variables whose values are taken on for every point over a given interval. In continuous distribution, probabilities of outcomes occurring between particular points are determined by calculating the area under the curve between 2 points. The entire area under the curve is 1. Now let's take a look at this particular image here. So the probability of the random variable x occurring between the values b and a will be determined by calculating the area under this curve, which is connecting these 2 points. So here, as we can see, the width is b minus a and the height is 1 by b minus a. So the probability will be the height into the width, means the area of the rectangle, and it will be 1. Let's go back to our continuous distribution again, and what we are seeing here is the entire area under the whole curve will be 1. This will be true in all scenarios. Now let's talk about a few of the examples of continuous distribution. There is uniform distribution, there is normal distribution, exponential distribution, t-distribution, chi-square distribution, f-distribution, and so on. But here we will talk about only few important examples. Now let's see what is probability density function, PDF. This is a function whose value at any given sample can be interpreted as providing a relative likelihood that the value of the random variable would be close to that sample. Or in other words, we can make it even simpler, like PDF will give you the probability of the random variable falling within the range of particular values. As we saw, what was the probability of x lying between the points A and B, we could determine that by calculating the area of the rectangle. Few characteristics of probability density functions are like total area under the probability density function will be 1, and the point where the probability density function is largest, because this is a curve and we can see where the value is large and where the value is small. So where we will see a largest value, it will be known as mode. For a continuous random variable, we cannot find the probability of x being a particular value. Rather than that, we can always find probability of x being in a range. So for probability of x having a specific value is 0. However, probability of x being greater than or lesser than a specific value is non-zero. Now let's talk about cumulative density function, or CDF. This is the distribution that plots the cumulative probability of x against x. So y will be the cumulative probability of x, and x is the original value of x. And few of the characteristics of CDF are, it is monotonically non-decreasing function. So it's not exactly the opposite of increasing, because non-decreasing means it is never decreasing. It might increase or it may be stable, but it is monotonically non-decreasing. So at any point of time it would not decrease. It might be getting saturated or it might be increasing, but it's non-decreasing. That's what it means. CDF should always reach the value of 1, and when PDF is plotted, the area under the curve gives you the probability CDF, the cumulative probability. So here This is the probability density function of uniform distribution, but if we calculate the area under this curve, that will be actually the cumulative probability. Now let's talk about the first example or the first kind of continuous distribution. This is uniform distribution or rectangular distribution. As you can see here, uniform distribution describes an experiment where there is an arbitrary outcome that lies between certain bounds A and B. And the bounds can be open or it can be closed as well. The probability density function of uniform distribution looks something like this. Fx is nothing but this curve, the expression for this curve, as we can see here. When x is between the points A and B, it is assuming the value of 1 by b minus a. But when x is beyond this range, whether it is below a or it is above the value of b, the curve is same as y equal to 0. So as we can see here, it is having 0. Fx is 0 for the range where x is less than a or x is greater than b. Next type of continuous distribution is normal distribution, and this is one of the most widely known continuous distribution. There are other names of normal distribution. You may sometimes call it Gaussian distribution or Gauss or Laplace Gauss distribution and so on. And this distribution is actually symmetric about its mean, or mean is also denoted by the sign mu, and mean median mode of normal distribution is equal. So we can also tell like the normal distribution curve or the normal distribution is symmetric about its mean, median and mode. That would also mean the same thing. Since mean, median, mode, all three things mean the same for normal distribution. Now for normal distribution, the probability density function looks something like this. And I will not go into much details about how we get these things. We can always go through them when we are talking only about normal distribution. Moving on to the next one, which is exponential distribution. As you can see, this is an exponential function, and exponential distribution describes a probability distribution of the times between the random occurrences. This is actually similar to Poisson distribution. However, the difference with Poisson distribution is discrete in nature, whether exponential distribution is of course constructed from continuous random variable. Now exponential distribution is right skewed. As you can see here, it is peaking at x equal to 0 and it is exponentially decreasing towards the right side or towards the direction where x is getting larger and larger. So here we have shown only till x equal to 5, but the range of x is actually 0 to infinity, and the apex will always be at x equal to 0, and the probability function of exponential distribution looks something like this. So when x is greater than or equal to 0, it will be, the fx will be lambda into e to the power minus lambda x. So fx will be lambda into e to the power minus lambda x for x greater than or equal to 0, and when x is less than 0, fx will also be 0. The CDF or cumulative density function looks something like this for exponential distribution. So for x greater than or equal to 0, the cumulative density function of exponential distribution will be 1 minus e to the power minus lambda x, and when x is less than 0, cumulative density function will also become 0. Next is standard normal distribution. Now this is just a variant of normal distribution, nothing else. This is actually the simplest variant of normal distribution. So the standard normal distribution is a normal distribution where the mean or mu is equal to 0 and the standard deviation sigma is equal to 1. When the mode is 0 and the probability density function becomes very small, around plus minus 3, the distribution is likely to be standard normal. Now let's talk about standardization. Standardization is a process given an arbitrary normal random variable x minus mu by sigma has a standard normal distribution. So when we know that x is a normal random variable, x minus mean by its standard deviation will always have standard normal distribution. Similarly, if we know that x has a standard normal distribution, ax plus b will have normal distribution with standard deviation equals to a and mean equals to b. The term x minus mu by sigma, or we are just deducting mean and we are dividing it by sigma, this value, this term is known by z-score of x. It tells us how many standard deviation away from the mean the random variable x is. So yeah, that's about continuous distribution, and this is just a random note I found out somewhere. We will see more details about these things when we will practice Excel. So yeah, that's it for today, guys. Hope you guys are enjoying this series, and let me know in comments what you guys would like to see in future. And as always, thank you so much for sticking by if you are still listening, and we will meet again very soon. Bye guys.